Hello, I'm Gordon Ritchie with Kollmorgen, and this is 2 Minutes of Motion. In this segment, we will be setting up a direct drive rotary and a disc for linear position. Because of their similarities, we will be doing them together. Setting up the direct drive rotary and the disc are the same except for the gear ratio in the disc. Both are using linear position units of centimeters, millimeters, meter, nanometers, inches, or mils. Starting in the disc, we can set up the gear ratio as we do with any other mechanism. If the ratio is set using a timing belt, we can use the number of teeth on the drive pinion and the number of teeth on the load pinion. If the ratio is from a gear head, we simply enter the number of motor turns and the number of load turns. For our example, a 12.5 to 1 ratio will be entered as motor 125 and load 10, since the values must be integers. Next, we decide on the custom position units to be used. In our example, we are going to use millimeters. The position units can be set to custom mechanics dependent. We then enter the radius of our load and the linear distance or portion of the circumference to be calculated. In our example, we have a radius of 254.648 millimeters, giving us a linear distance, also circumference for 1 revolution, of 800 millimeters per rev. Returning to the screen for direct drive rotary, we see that everything is the same as it was in the disc, except there is no place for a gear ratio. We simply decide on the custom position units, again our choice was millimeters, and we enter our radius of 254.648. Position units are set to custom mechanics dependent. In both the direct drive rotary and disc, this will result in a motion task reflecting the same for its position units. In the unit screen, you will notice that there is disc angular and disc linear. Disc angular is concerned with positioning the load in angular units, such as degrees, and working in 1 revolution of the load. Disc linear is concerned with positioning the load in linear units found on the circumference of the load as based on the radius. Keep in mind the radius with which you might be working may lie physically inside the load. I'm Gordon Ritchie for 2 Minutes of Motion. Join me in our next segment.